This is part 2 of the video illustrating how to graph a secant or a cosecant function. In part 1, I graphed the related cosine function in this example, so if you haven't seen that, you might want to go and view that first. But if you're comfortable graphing sine and cosine functions and just need more information about secant and cosecant, then this would be a fair place to start. Alright, so I wanted to begin by talking about the relationship between the secant and cosecant graphs with their reciprocal functions. And I've laid out the overall steps here that you can use to graph a secant or a cosecant function. So step 1 that I put here would be to graph the reciprocal function, which, like I said, we did for this particular example in part 1 of the video. But just talking through this overall. So, for example, if you wanted to graph a secant function, you would begin by graphing cosine. So I'm going to do a quick cosine sketch here. If it's cosine of x, then, oops, I need a pen. You get a typical cycle as x ranges from 0 to 2 pi. You'd also want to know the basic shape of the cosine graph. I'm going to scrunch my units in here. So 1 and -1. Alright, so cosine starts and ends at its maximum value. So if it's just plain old cosine of x, that maximum value is 1. In the middle, it reaches its minimum value. Halfway between that maximum and minimum value, there's an x-intercept. And halfway between the minimum and the maximum value in the second half, you get another x-intercept, and so the shape of the graph looks like this. Now, I'm going to move on to step 2 with regard to secant. So once you've graphed a reciprocal function, in the step 1 here, step 2 is to draw vertical asymptotes through the x-intercepts. And to talk a little bit about why. So let's take this point right here at pi over 2. So cosine of pi over 2 is 0. Secant is 1 over cosine. So when x equals pi over 2, you've got a 0 on the denominator, which you might remember typically gives you a vertical asymptote in your graph. So those x-intercepts are places where the denominator zeroes out, and so the graph has a vertical asymptote. Now, step 3, extend the graph from the maximum and minimum points in the reciprocal function. What I mean there is, well, here, let's go back to this secant x example. So I take this maximum point here, and as the cosine function approaches 0, so as the y value is something like 0.001 or so 1/1000, things like that, the secant graph is the reciprocal, and the reciprocal of 1 over 1,000 would be 1,000. So as the value of cosine gets very small here, close to 0 through positive values, the value of secant is going to skyrocket, and so it's going to go up to infinity here. It won't ever cross the vertical asymptote. The same thing if you look at the far right side of the graph here. As the y value gets very close to 0 through positive values, like 1/1000th, the reciprocal value again is going to approach infinity. And the same thing happens in the opposite direction here in the middle. So if the value of cosine is, say, -1/1000th, a very small negative number, then the reciprocal is -1000, so it's diving down to negative infinity here and here. But one other thing about this graph, and I know it's squeezed in there, the graph of secant should not cross its vertical asymptote, and the same with cosecant. And actually, no function is going to cross, the graph should not cross the vertical asymptote. So let me just put down here, do not cross vertical asymptotes, ever, with your graphs. I'm going to just abbreviate here so I don't use up all my time writing. If you were going to graph a cosecant function, it would work much the same way. So you would first want to graph the sine function. So sine starts and ends at 0. It has another 0 in the middle. It goes up. Let's see, I want to keep my colors matching here. It goes up to its maximum in the first half, goes down to its minimum in the second half. So if we wanted to graph cosecant from there, we would put vertical asymptotes through those x-intercepts. those 3 x-intercepts, and then take those maximum and minimum points and extend the graph either up to positive infinity, or when the value assigned is negative, it's going to extend down to negative infinity. And so you get those alternating parabola shapes. Now, going to this specific example, so the 1/2 secant of 1/2 x minus pi over 4. In part 1 of the video, we graphed the reciprocal function 1/2 cosine of 1/2 x minus pi over 4. And I'm realizing now I probably should have done this beforehand, but I'm going to go ahead and graph that cosine function again. So we found out that the one cycle of the graph, we solved the inequality, and we figured out that the one cycle in this graph is going to occur as x ranges from pi over 2 to 9 pi over 2. So if you were graphing this cosine function, that's the first thing we would want to do is mark off those x values. So here's 1 pi over 2. So I'm just going to count over by pi over 2's. Here's 2, 3, 4, 5, 6, 7, 8, 9, I think. Hopefully. Let's see. 2, 3, 4, 5, 6, 7, 8. Yeah, here. 9 pi over 2. So the cosine graph starts and ends at its maximum value of 1/2. And I'm going to go ahead and mark that minimum y value of negative 1/2. All right, the amplitude for this cosine graph is 1/2. So the cosine graph is going to start and end at that maximum value of 1/2. Right in the middle, so since there's 8 spaces between pi over 2 and 9 pi over 2, 4 spaces over 1, 2, 3, 4, we get this minimum value of negative 1/2. Since there are 4 spaces between that initial point and that minimum point, if I count 2 spaces over, that's going to be where I get that x-intercept. So here and here, I'd get an x-intercept. And so this is the graph of the cosine function. Which again, you can look at part 1 of the video to see that whole thing in more detail. Now, going through the steps we laid out a second ago for graphing the reciprocal function. So I'm going to graph the actual function we were asked for in red here. We draw vertical asymptotes through the x-intercepts, so here and here. And then you have the graph extend upward from those maximum points here and here as you approach the vertical asymptotes. And you have the graph extend downward from that minimum point here and here. And there in red is your graph of 1/2 secant 1/2 x minus pi over 4.